Okay, now today about new chapter polynomial ring. Let me start it from the definition. That what is a polynomial? What is a polynomial? We will start. The definition is let D be an integral domain and X be a variable, then the expression of the form like a0 x 0. a0 x 0 means x0 is equal to 1, so it is a0. a1 x 1, a2 x to the power 2, a3 x to the power 3, and so on, plus a and x to the power n, and plus so on. That can be written as in the summation form ai x to the power I, where ai's are the elements of integral domain D. Okay, in this case, where only the finite number means some of them a0, a1, a2, a3, an, some of them may be 0 but not all, where only the finite number of ai's are non-zero, or only finite ai's are 0. Then such an expression is called polynomial of X over D. Means they are the polynomial of the integral domain D. Okay. In this case, you can see here that this polynomial is expressed infinitely. So again I will give you another definition. Finite polynomial if D is an integral domain and X be a variable, then the expression of the form a0 x 0, a1 x 1, a2 x 2 up to an x n, that can be written as I is equal to 1 to n ai x is called, where only sum of AIs maybe 0 is called finite polynomial of X over D. And in this case, the coefficient related to this highest degree here, an is called leading term if an is not equal to 0. If an is not equal to 0, then it is a leading term or leading coefficient or leading. It means that this is the leader coefficient of the polynomial.
Why, sir?
And if an is equal to 0 for every n is the element, for every n, suppose that, then you know that every term of the polynomial will vanish, will be equal to 0. Suppose 0 भइहाल्छ हैन?
त्यो त 0
Then the polynomial that was the function of X is called a 0 polynomial. And if an is equal to 1, okay,
yeah, is equal to 1
for every n, then it means a1 is equal to 1, a2 is equal to 1, a0 is equal to 1, means everywhere there is the coefficient in the form of 1. Okay, then in that case we say the polynomial is, then the polynomial fx is called monic polynomial, and this is called monic. The word monic is used. Okay, means if every constant, every coefficient is 0, then it is 0 polynomial. If every coefficient is 1, then it is a monic polynomial. अलिकति मैले यसमा करेक्सन गरेँ, एभ्री n को आवश्यकता छैन यसमा, यानी यसको हायर डिग्रीको मात्रै, if it is 1 for only higher degree, then the polynomial fx is called a monic polynomial. I will write example. Like in the example, if fx is equal to 2 plus 3x plus x square, You can see here the coefficient of this x square is 1. On the basis of this leading coefficient, we say that it is a monic polynomial. Okay, this is actually definition. And suppose that there is any polynomial like 4 minus 3x plus 4x square plus 3x to the power 4 minus cube minus 4x to the power 4. Then what is the highest degree of the polynomial? That is 4. And the coefficient is non-zero. Is a polynomial of degree 4. Okay. Now I will. So what about equality of polynomials?
Equality to
Two polynomials. One is fx a0 a1x a2x square and so on up to an x to the power n, and another polynomial gx that is equal to b0 b1x b2x square plus to suppose that it is
A0x0 plus A1x1 यस्तो हुँदैन सर
a1 x1 लेख्नु र नलेख्नु त एउटै कुरा हो नि त, पावर त बनै छ नि त
सर। तर यताको A0 लेख्नु भएको छ अनि त्यहाँ
a0
लेख्नु
x0
पर्दैन।
भनेको x0 भनेको त 1 त हो नि त, x0 is 1, therefore no need to write. लेखे पनि भयो नलेखे पनि भयो because x0 is 1. Okay. So these two polynomials are said to be equal if these two polynomials are said to be equal if their degrees should be equal, means m is should equal to n, means number of terms they should contain same number of terms. If m is equal to n and the coefficients they are identical, means ai is equal to aj for every ai is equal to bi, ai is equal to bi for every I. Okay. Means a1 is equal to b1, a2 is equal to b2. On this way they all will be equal when we say that the two polynomials are equal and their degree are also equal. M is equal to n means degree of fx is equal to degree of gx. Okay. After this sum of polynomials, the sum of two polynomials of equal degree can be we can add to two polynomials which they have equal degree. If they have different degrees of polynomial, then they cannot be added. So sum is only possible if they both have same degree of polynomial. The sum of two polynomials of equal degree is given by, suppose that fx is a0 a1x a2x square up to an xn, and the polynomial gx is given by b0 b1x b2x square plus bnx to the power n, then the sum of x or minus, both can be defined on the same manner, is given by a0 b0 a1 b1x plus a2 b2x plus dot 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 up to an plus bn x to the power n. Okay, in shortcut you can write sigma I is equal to 1 to n. This is ai plus bi x to the power I. So in this way two polynomials can be added. Now product of two polynomials. Suppose that there are two polynomials and we have to show their product. Let the first polynomial fx is a0 plus a1x1 plus a2x2 plus up to anxn, and another polynomial is there gx is equal to b0 b1x plus b2x square plus bnx to the power n, then their product is defined as, their product is defined at fx into gx, that is given by c0 c1x c2x square and c m plus n x to the power m plus n. Here one question arises that what is the value of these coefficients c1 c2, where any of these ci's can be calculated by using formula ci is equal to a0.
तपाईँको आवाज कहिले आउँछ कहिले आउँदैन
That is your connection problem. अहिले आएर छ? Are you hearing me? Where ci can be shown as a0 bi plus a1 b I minus 1 plus a to b I minus 2 plus and so on. It means the value of a is increasing, a0, a1, a2, a3, and value of bi is decreasing, bi minus 1 on this way, plus a finally will reach to ai and b will decrease to b0.
B0.
By using this formula, you can calculate c0, c1, c2, c3, every value you can calculate. Actually, in general, we know how to multiply two polynomials. These are in our practice from very lower classes. But here, we are given now a certain formula that by using this formula, we can find product of any two polynomials. Okay, so this is the formula of finding product of the two polynomials. Now about division of polynomials.
Okay.
Division of polynomials. Let fx and gx be two polynomials in a set of collection of polynomials fx, then not then the polynomial gx is said to be divisor or factor of fx if there exists some another polynomial qx in fx such that fx can be expressed as the formula of gx into qx. Okay, or if it is a complete divisor only, in this case you can see that remainder is 0. In other cases remainder also may occur, remainder पनि आउन सक्छ अरू केसेसहरुमा. अब if gx does not divide fx, if g does not divide fx, then there exists two polynomials. One is qx and another is rx in the polynomials set fx, such that fx can be written as gx into quotient function gx plus the remainder function rx. In this way also we can write here rx is the remainder function. Okay.
Voice, sir.
And properties which are followed by polynomial. Properties of polynomials. Division algorithm. इसमें तो डिवाइड करने बारे में बात है. For any non-zero polynomials fx and gx over the field f, field f में and gx is not equal to 0, means the divisor should not be equal to 0. There exists a unique polynomial here, and Rx is another unique polynomial, such that I can write fx is equal to gx into this is the same result what we wrote just before, where Rx is 0 or degree which is less than the degree of divisor gx. Okay, so this is called division algorithm, and remainder theorem. Remainder theorem: if a polynomial fx is divided by a linear polynomial, exactly divided by a linear polynomial, yes, minus c, then always the remainder will come by fc. Means when f minus c divides the function fx, then always the remainder will be given by fc. If in the polynomial you will put the value of x is equal to c, then directly we can derive the remainder. We need not to divide any function. Direct you can calculate the remainder. So this is the remainder theorem, and now factor theorem. If a polynomial x is divided by the linear polynomial x minus c and if the remainder is equal to 0, then f minus p is a factor of fx. What is the fundamental theorem of algebra? A polynomial fx is divided a polynomial fx over a field of complex numbers p of degree n has exactly n root space.